Hello dear students, today in this video I am going to solve question number 3 of exercise 8.1. This proof is quite long, so you should give concentration fully, then you will understand it. What is the question? Let's see. Show that if the diagonals of a quadrilateral bisect each other at right angle, then it is a rhombus. That means when the diagonals of a quadrilateral bisect each other at right angles, then that quadrilateral is a rhombus. We need to prove that. We already know that diagonals of a rhombus bisect each other at right angle. Now we have to prove it geometrically. So what to do first? We have to take a quadrilateral. Here parallelogram is not set. Point is that if it would have said that it is parallelogram, then it would be easier to prove, but here it is said quadrilateral, so we have to take any quadrilateral. Suppose ABCD is a quadrilateral, any quadrilateral, not parallelogram. ABCD is a quadrilateral and their diagonals are AC and BD, which intersect at O, and it is already said in the question that they produce 90-degree angle, right angle here, and they bisect also. These are two sides are equal and these two sides are equal, so we need to prove that ABCD is a rhombus. What is rhombus? Rhombus is a parallelogram where all the sides are equal. So first of all we have to prove that this is a parallelogram. In question it is said it is quadrilateral, so first of all we have to prove that ABCD is a parallelogram. Then we have to prove that all sides are equal. There are two steps in this sum and very important and quite long. So first of all we will prove that this quadrilateral is a parallelogram. So write what are given. Solution. What is given? Let in quadrilateral ABCD the diagonals AC and BD bisect each other at right angle at which point O. That means that is what are given. AO is equal to OC, BO is equal to OD, and these all angles are equal 90-degree. Angle AOD, angle AOB, angle BOC, angle COD, all are equal and 90-degree. It is given in the question. Since it is said that the diagonals bisect each other at right angles, therefore their AO is equal to OC and BO is equal to OD. AO is equal to OC, BO is equal to OD, and this all angle AOD, AOB, BOC and COD, all angles are right angle. It is said in the question. Now we have to prove that this quadrilateral is a parallelogram. So to prove parallelogram, either we can take these two triangle or we can take these two triangle. If we can show that this angle and this angle are equal, then these two sides will be parallel. In the same way we can prove that these two sides are also parallel. So first of all let's take these two side triangle. Prove. What to prove? In triangle AOC, and now see, since we have taken triangle AOC, order is mandatory here. AOC. So AOC, AO is equal to OC. We are taking from this vertex AO, so we have to take from this vertex CO. If we take AOD, then we have to take COB. Why? Because AO is equal to CO. Then AOD and COB, and BO is equal to OD in triangle. So triangle COB, we cannot take BOC or OBC or OCB like that. In these two triangles, what are equal? AO is equal to CO. AO is equal to CO, given BO is equal to, or this angle, angle AOD is equal to angle COB, alternate angle. Then this side BO or DO is equal to angle OD is equal to OB, since these two sides are equal, given. So by side angle side by side angle side criteria, these two triangles are congruent. Therefore triangle AOD and triangle CO is congruent to triangle AOB is congruent to triangle. This is congruence and COB, side angle side criteria. Now therefore what can we write? We need to show alternate angles equal. Angle, we can prove that OAD angle and OCB angle, these two angles are equal. Therefore angle OAD is equal to angle OCB, CPCT, corresponding parts of congruent triangle. But these angle, these two angles OAD and OCB, these two angles are forming alternate angle and become equal. So they are, therefore these two sides will be parallel. These are forming alternate angle and are equal. Therefore what can we write? We can write AD is parallel to BC. Now it becomes a transversal. So these two are congruent angle, alternate angle, and therefore these two sides are parallel. Therefore AD is parallel to BC. Similarly, we can prove AB is parallel to DC. Similarly, AB is parallel to DC. So since both the pair of opposite sides become parallel, therefore ABCD is a parallelogram. ABCD is a parallelogram. Now see, just we have proved it parallelogram. Now we have to prove that all sides are equal, because in rhombus is a parallelogram where all sides are equal. So to prove all sides are equal, or it is sufficient to prove one adjacent sides of a quadrilateral are equal, then it is a rhombus. Now see, if we take these two triangles AOD and COD, then if we can show that this side and this side are equal, if these two sides become equal, then they are forming adjacent side of parallelogram. When the adjacent sides of a parallelogram are equal, then it becomes rhombus. Why? Because the AD is equal to BC, parallel, and these two sides are also parallel. So now we have to prove that these two, any two triangle we have to take. So take triangle AOD. If we take AOD, then we have to take COD. Now in triangle AOD and triangle COD. See, in these two triangles, in triangle AOD, AO is equal to CO. It is equal. These two angles are right angle, and this is the common side. So these two triangle become congruent. So if when they will become congruent, these two sides will be equal. So we can prove that in triangle AOD and COD, we can write AO is equal to CO, given angle AOD is equal to angle COD, both are 90 degree, given. Then OD is equal to OD common side. We will write it full from common side. Therefore triangle AOD is congruent to triangle COD by side angle side. So therefore we can write these two sides are equal. Since these two triangles became congruent, AOD and COD, so these two sides will be equal. Therefore AD is equal to CD. Therefore AD is equal to CD. In this way we can prove all the sides are equal. So give it equation number 2, and this line is equation number 1. So from 1 and 2, what can we conclude? ABCD is a parallelogram, and in this parallelogram, one pair of adjacent sides are equal. When one pair of adjacent sides become equal in a parallelogram, then all the sides become equal. Therefore from 1 and 2 we can write ABCD is a rhombus. Therefore from 1 and 2 we can say that ABCD is a rhombus. ABCD is a rhombus. So it is quite long sum. You have to watch the video again and again, so that you can understand the concept. So next see question number 4. It is also quite long. Show that the diagonals of a square are equal and bisect each other at right angle. Now it is said that in a square the diagonals are equal and they bisect each other at right angle. So we have to prove that AC is equal to BD diagonals and they bisect each other. That means AO is equal to CO, PO is equal to OD, and then we have to prove that it is they bisect each other at right angle. So first of all, right, let us consider a square ABCD whose diagonals AC and BD intersect. We cannot write bisect because we need to prove bisect. Intersect at O. So diagonals intersect at O. We need to prove that they are equal, bisect each other, and they are equal. So to prove, we need to prove 3 things here. Number 1, we have to prove that diagonals are equal. So write 1 number, AC is equal to BD. 2 number we need to prove what? They bisect each other. AO is equal to OC and BO is equal to OD. And 3 number we need to prove these angles are 90 degree, or any one of the angle is 90 degree. We need to prove that angle AOD, angle AOB, angle BOD, angle COD, BOC, this one equal 90 degree. It is sufficient if we prove one of the angle is 90 degree, then it is sufficient. Then all angles will be 90 degree. So first of all, prove for one number AC is equal to BD, we have to take two such triangles so that both the diagonals include one number. So for one number C, we need to prove AC is equal to BD. So we have to choose two such triangle so that both the diagonals come. So if we take these two triangles, see, DAB or DBA, then diagonal DB will come. If we take DA, then we have to take CBA, then this diagonal will come. That means this triangle and this triangle, whole triangle. So in triangle DAB, since we have taken DAB, then we have to take CBA, triangle CBA. In these two triangle, since it is set square already in the question, we can write AD is equal to what? BC. AD is equal to BC, given, it is given. Now see, in triangle DAB, this whole angle, and in triangle CBA, this whole angle is 90 degree. So you can write angle DAB is equal to angle CBA. Why? Both are 90 degree, because it is a rhombus, it is a square. In square all the angles are 90 degree. Now again, AB is the common side. DAB, in triangle DAB, AB is present, and in triangle CBA also AB is present. So AB is equal to AB or BA. You can write BA. AB is equal to BA. Same thing, common side, you will write full form. Therefore, triangle DAB is congruent triangle CBA by side angle side criteria. Side angle side. Therefore, what can you write? Now, in triangle DBA, DB is present, and in triangle CBA, AC is present. So, AC is equal to BD, CP, CT. One part is proved. So for next part 2 number. For next part, see what we need to prove in next part. AO is equal to OC, BO is equal to OD. AO is equal to OC or CO, and BO is equal to OD. You see, in this case we have to choose two such triangles so that all the sides come. So if we take these two triangle AOD and COB, then all the sides will come. AO, CO, BO and DO, all sides will come. So we have to choose these two triangle, either these two triangle or these two triangle for second part. So in triangle AOD and triangle COB, in these two triangle AOD and COB, which parts are equal? Let's see. This side and this side are equal in these two triangle. So we can write AD is equal to BC. AD is equal to BC. Why? Because ABCD is a square, or you can write given. Again see, in this two triangle, this angle and this angle are equal, vertically opposite angle. So we can write angle AOD is equal to angle COB, vertically opposite angle. Angle AOD is equal to angle COB, vertically opposite angle. Next see, if in these two triangle what are equal, this angle and this angle, angle OAD and angle OCB are equal. Why? Because they are forming what? Alternate angle. Why they are this time alternate angles are equal? Because ABCD is a square set. It is set square. So square is nothing but a parallelogram. So in parallelogram, these two sides are parallel and this is the transversal. So these two angles are equal. So you can write angle OAD, angle OAD is equal to angle OCB. So alternate angle, alternate angle. Therefore these two triangle will become triangle AOD is congruent to triangle COB by what? Side angle angle, side angle angle, or angle angle side. Now see, since these two sides are equal, now we can directly write AO is equal to CO and BO is equal to DO or OD. Therefore AO is equal to CO CPCT. Again BO is equal to DO CPCT. So second part is proved. So last part, we need to prove one of the four angles is 90 degree. So in this case we have to take two such triangles so that one linear pair angle comes. So if we take these two triangle, angle AOB and triangle AOB and COB, then these two angle will come and they are forming linear pair angle in the same line. So we have to take either these two triangle or these two triangle or these two triangle or these two triangle. So we have to take two adjacent triangle so that two linear pair angle comes. Then we can prove that these angles are what? Equal, forming 90 degree angle. Before that we have to prove that these two triangles are congruent also. After congruent, these two angles will become equal and their sum will be 180 degree. So now take for 3 number part, we have to take these two triangle. In triangle AOB and since we are taking AOB, then we have to take COB because AO and CO are equal. In triangle COB, so in this two triangle, AO is equal to CO, AO is equal to CO. This just proved. This one is just proved in the previous section. Again see, these two sides are equal. AB is equal to BC, given because ABCD is a square and OB is common side. OB is equal to OB, common side. So by side criteria, these two triangle become congruent. Therefore triangle AOB is congruent to triangle COB by side. So since they become congruent, therefore we can write angle AOB and COB are equal. Angle AOB and angle COB, CP CT. But see, these two angles AOB and COB are forming what? Linear pair angle on the same line. So we can write angle AOB plus angle COB is 180 degree. So when they become 180 degree, AOB in COB we can write AOB plus COB. COB means AOB. Here COB means AOB 180 degree. So we get twice AOB. Twice of angle AOB is 180 degree. So angle AOB is 90 degree. Therefore, from it, give it equation number 3 and previous one equation number, this is equation number 2 and this is equation number 1. So from all this part, no need to give the equation because already these are proved. So this is the proof of this sum. So you can write, or you can give the equation 1 2 3. From 1 2 3 we can write from 1 2 and 3 we have proved that the diagonals of a square are equal and bisect each other at right angle. Thank you.